Hello everyone, this is Data 620 Week 8 assignment, High Frequency Words. Warner Alexis and I, Mahmud Hasan, work together in this assignment. So in this assignment, we have used Gutenberg corpus from the Natural Language Toolkit library. This corpus basically has a collection of classic literary texts in plain text format. So in this assignment, we've used Emma text. So Emma basically a famous English novel written by Jane Austen. It is a 19th century English literature rich with vocabulary, distinct dialogue and character interactions. And the Emma text dataset is commonly used in text analysis and natural language processing. So this assignment is divided into 7 questions. So by doing the coding analysis, we answered all the 7 questions. So the first question is about to choose a corpus of interest. And I already mentioned that in this assignment, we choose Gutenberg corpus. So as you see that we first downloaded the Gutenberg corpus, then we listed all the available texts in this corpus. Here you see the list. The first one is the Emma text, and then we printed the characters and the size of the text. So next we basically clean the text by removing extra spaces or indentation from the MRAW file. We created a regular expression pattern, which is like a token pattern to identify all the proper words made of letters, including like words with apostrophes like don't or it's. Then we defined a tokenization function that splits the text into individual words, I mean the tokens, and then converts them all to lowercase for consistency. So to answer the second question, which is about to how many total unique words in the corpus. So to do that, at first we tokenized the text, and then we computed all unique words and counted them and created a frequency table to understand both the vocabulary size and the total word distribution in Emma. And you see the total unique words in this corpus is 7,204. And then next we worked on the stop word removal, and then part of speech tagging. So but before that we answered question number 3, which is how many unique words cover half of all tokens. So basically to do that, we first sorted all words by their frequency, starting from most common ones. Next we set a target, which is like half of the total word occurrences in the text. Then we added up each word's count one by one until the cumulative total reaches 50% of all words. And then we recorded how many unique words were needed to reach that point, and the number is 56, as you say. So next we worked on the stop words and part of speech tagging. To do that, at first we imported tools from NLTK. Then we downloaded the built-in list of English stop words like the and is, etc. And then we added a few custom ones such as Mr., Mrs., Miss, could, would, said, and so on. which basically appear frequently in EMA but don't add much meaning. Then we removed all those top words from our token list so that only the more meaningful words remained. And after that, we used part of speech tagging to label each remaining word with its grammatical role, such as a noun, verb, adjective, or adverb. And finally, we kept only those content words like nouns, verbs, adjectives, and adverbs, since they carry the real meaning of the text. So next, we identified the 200 highest frequency words, and to do that, we first counted how often each remaining content word appears in the claimed text by using counter function, and then we selected the top 200 most frequent words to focus on the most significant vocabulary in EMA. And then we organized these top words and their counts into a data frame, which basically makes the data easier to view and analyze. And after that, we calculated each word's relative frequency, which basically shows how often it appears compared to the total number of content words. And finally, we displayed the top 200 content words, which is now basically free of stop words and any character names. So basically in this step, we identified and organized the most common meaningful words in EMA, which basically gave us a clear picture of which words dominate in the novel's language. So that's all from me. The rest of the analysis will be discussed by my teammate Warner. So thank you so much for listening to me.
So, good afternoon. I'm briefly gonna talk about question 5 to 7. So, let's start. So, this graph show the relative frequency distribution of the top 200 word in Jane Austen EMA books. So, what we did, we remove some of the stop words and common words. So, each point we present a word ranked by how often it appears in the text. So with the most frequent word on the left and less frequent one towards the right. So the steep drop at the beginning shows the few words occur very often, while most words appear much less frequently. So this pattern is typical of natural language and follow Zipf law, which state that word frequency is a corpus. Word frequency in a corpus is inversely proportional to its rank. In its simpler term, the most common word dominate the text, but has rank increased, frequency decreased rapidly, forming a long tail. So the curve in this plot reflect that behavior, confirm that EMA, like most literary work, has a small set of highly frequent content words that shape much of the narrative, and large number of words that occur rarely, adding richness and variety to Austen language. So, so when you go down to the question 6 now, so this section of the code tests whether the word frequency in the text follow the Zipf law. So it first rank all words by frequency, then calculate each word's relative frequency, then convert both rank and frequency to the logarithmic value. So using the log value as a linear regression is performed whether the slope b and r square value are computed. So if the slope is close to -1 and r square is close to 1, indicate that the data closely follow Zipf law. meaning that the frequency of a word is inversely proportional to its rank in the corpus. So in short, this code check if Austin AMA exhibit the natural linguistic pattern found in most human language. So the Zipf plot show the relationship between the log word rank and the log word frequency in Jane Austen AMA textbook. So the clear downward sloping straight line indicate that as the word rank increase, its frequency decrease proportionally, which is consistent with Zipf law. So in other words, few words occur very frequently while most appear rarely. So the neolinear alignment of the point of log-log scale confirm that the distribution of words in AMA follow the typical linguistic pattern found in natural language, demonstrating how Austin vocabulary to diverse and still added to the universal rule of frequency imbalance. So the summary statistics support this interpretation. So the corpus contains around 161,000 tokens and about 7,204 unique words, which show that Austin used a rich but structured vocabulary. Interestingly, only 56 unique words account for half of the entire text, meaning that few words occur repeatedly while many appear rarely. So that's why we see the slope is negative 139, very close to the theoretical Zipf values. And one, the R square is about 0.98, show an excellent fit, confirming that the word frequency in AMI is strongly correlated with Zipf distribution. And one thing what we want to add is that altered AMA follows Zipf law, like most natural language corpora. Its high frequency words reflect the 19th century literacy styles with names such as Emma, Harriet, and social titles like Mr. and Lady, and emotional verbs such as think, feel, and say. In contrast, modern corpora include news, only text, and scientific writing feature more diverse contemporary and informational language. Thus, while the frequency pattern is similar, it might focus on relationship and emotion rather than information topic. Thank you.